This method describes the production of an isotopically pure thorium-229 ion beam following the alpha decay of uranium-233.
The main advantage of this technique is that it allows to study thorium-229 ions in a low-energy nuclear-excited state that is relevant to nuclear clock development.
Demonstrating the procedure will be Ines Amersdorffer, a student from our laboratory.
A uranium-233 source is mounted in this setup for creating an isotopically pure thorium-229 ion beam. The vacuum chambers have been evacuated and baked out to prepare for the experiment. The setup is behind the electronics used to monitor and control the system. Researchers interact with the electronics primarily through computers, which also collect and display the data. This cutaway schematic depicts elements of the apparatus. Consider the steps from generating the thorium-229 isomers in the buffer gas stopping cell to detecting them with a CCD camera. A 290 kilobecquerel large-area uranium-233 source produces via alpha decay thorium-229 nuclei, including 2% of first excited state isomers. Fast thorium nuclei escape the source and are thermalized in an ultra-pure helium atmosphere buffer gas stopping cell. Next, they encounter an electric funnel system. Its radio frequency and direct current electric fields guide them towards an extraction nozzle. The supersonic gas jet from the nozzle takes the nuclei into a vacuum chamber with a radio frequency quadrupole structure. The structure acts as an ion guide, phase space cooler, and potentially a Paul trap. The next vacuum chamber